So I want to kind of go part by part, and then first understand the state of industry from say Deepak and Harshit, and then go into what will be the future. So what is the current state of the industry, Deepak, and what do you think are the current technology trends, especially in semicon?
Yep. So no, I would recap little bit into the past, and Raghuji may agree with me because he's longer in this industry than me. So no, going back to the time in 1970s when the transistor was invented, microprocessor was invented, and first chip was built, right? So industry consistently made progress by reducing the transistor feature sizes, right? So transistor scaling that fueled the innovation for about 2.5 decades in semiconductor industry, right? So that was the PC era. I say it was a PC era. Then we moved to PC and networking era, where industry was building complex SoCs, right? Then from PC and networking era to we moved to laptops and the mobile era, where the low power design with high performance demand, was the norm there, and that was fueling the innovation in the industry, right? And from the mobile era, now we are at the start of beginning of the new era, where we see a lot of emerging use cases and AI, cloud, the connected devices, the autonomous vehicles, e-vehicles, right? So that's the current demand of the market. These are the different market requirements, right? So during the mobile and PC era, the complex SoC that we were building, the methodology that we were using was using the IP reuse, because the SoCs were so complex that you want to build the SoCs faster. So you want to have the IP reuse across product to product and across the market segments, right? So EDA advancements in this space, right, that enabled development of complex SoCs faster, right? Now today we have this all these use cases that I'm talking about, that requires us to have heterogeneous architecture, right? So where we have a performance CPU, we have a power optimized CPU, we have GPU, we have accelerators on the same package. Basically that's a heterogeneous architecture, right? So that's increasing the complexity by 100x. And recently, with the current trends, we are hitting the power and power density challenges on the chip, right? So industry is now moving towards more advanced packaging, the system on package, right, using the chiplet based method, right? So this chiplet based method, it's allowing you to have, wherever you require high performance, you can use the latest and the greatest technology node. You can use the latest and greatest technology node and build the chiplet, right? And wherever there are cost sensitive segments, or where you don't have performance as a critical need, you can still use your previously built chiplet on the older technology node. So the advanced packaging today allows you to mix and match chiplets and build the advanced packages, right? So that's one trend we are seeing today. The other 3D die stacking technology, which allows the Faveros allows you to stack the two dilates using the low latency interface, right? So that's another trend. And the chiplet to chiplet, we have industry standard interface defined UCI, which you can use to interface the chiplet. You can have chiplets from one vendor and you can have chiplets from other vendor, and they can still be packaged on the same package, and you can meet the needs of the market, right? So I see that from PC era to PC to networking era, and to mobile era, and to the current era, the number of and the variants of the chips, the complexity of the chips is growing significantly.
Got it. Got it. So as in, you took us through the entire, journey of semiconductors. So and Arshad, on a more futuristic way, how do you think Juniper is adapting to these new technologies that are coming up, and how do you see Juniper leading the way?
Sure. So I'll add to what Deepak said. We have entered a very interesting phase because there was a phase 10 years back where, or 15, for around 15 years, when we went from somewhere around 90 nanometers all the way up to 3 nanometers, right? In some 15 years. And it's going to be very difficult beyond this to scale the technology. So what happened when 90 to 3, we every time you can take the same design, just go to the next node and you just get 2x the performance. May not have to do anything new. But now, because now we have kind of frozen at 3 nanometer, and 3 nanometer is extremely costly, right? Uh, this new chiplet thing has come up, right? And that has opened up a huge innovation in the industry, especially for people like Juniper, who don't own a fab, who are very cost sensitive, right? They are a ASIC kind of a fabless vendor. That's another term which we use. So what we can do is we can grow the performance of our networking device by building multiple chiplets, connect them in a package, co-package them, and still achieve the same scale. Because whatever you're getting from just going down to the next node is not available anymore, right? This is also opening up another field where now more innovation may come in the PC architecture. You may design a chiplet which will do a very specific job, and you can go with maybe a x86 or ARM, and that becomes another SoC or package which can do that. So at Juniper, we are exploring all this option. We already have a few devices on the market like that. Again, we don't sell semiconductor; we sell a box which has all this innovation into it.